Richard Helsham, so 300 years ago, and since then the School of Physics has just gone from strength to strength and is the wonderful, amazing school that we have today. So it was especially, I think, exciting when actually Louise Bradley and the team who were organising Physics 300 approached me and asked, could we devote this memorial discourse to really key figures in physics. And there is no better person than I can imagine than Werner Blau. There's only one Werner Blau, I feel, and to give this talk. Werner himself was an amazing, or is an amazing researcher here in Trinity. I actually had the pleasure of attending some of Werner's Festschrift, and one of the things that stood out for me when I was there was not alone how brilliant he himself was, but how he passed that on to so many generations of other people, and how they went on to do fantastic research themselves. So I, for one, am very looking forward to what Werner has to say. So the two professors that we have today that we're going to be hearing about is Professor Brian Henderson and Professor Daniel Bradley. I'm really delighted to see that we have Professor Bradley's family with us, and they're very welcome. And I should have also actually welcomed Cord, the German ambassador, at the beginning, who delighted you're here as well. Cord, you're great for turning up at things at Trinity, and you give us lots of support, so thank you very much. I think we're going to be in for a treat. One of the things that stood out to me over the last few days when especially on Friday when I was over at the Physics 300 celebration, was the sheer, I suppose, excitement of the physics community, the delight of coming together to remember the history of it. And it was it was so incredible to see the number of alum that turned up and how everyone actually, the joy of the occasion and the magnificence of the occasion. So I know that Eric Finch, who's sitting here, he gave the most wonderful talk. He managed to cram 300 years of history into 40 minutes. So Werner, you only have to focus on 2 people in 50 minutes. So you have a much easier task, but no pressure in following the wonderful discourse that we heard last week. So with that, I'm going to hand over to Werner, and delighted to see you here, Werner, and I'm really, really looking forward to hearing the story of these two wonderful Trinity people on this very special Trinity Monday. So thank you.
Provost, fellows and scholars, Herr Botschafter, ladies and gentlemen, colleagues and friends. I would like to extend a special welcome to Martin Bradley and Daniel, named after his grandfather, and Benjamin, who are the only ones of Dan's 15 grandchildren, I should say, who study at Trinity. I'm most grateful to be allowed to join the distinguished line of previous Trinity Monday speakers, dating back to 1895. Many thanks to the Provost and the School of Physics for their kind invitation, and to the many friends and colleagues who have provided me with insights, information, and advice on the preparation of this lecture. So, let me start at a day in October 1983. This is departmental coffee in the physics seminar room on the first floor of the Dixon Laboratory or Dixon Hall, which since has given way to the Znajan building. Probably on Friday, the 14th of October 1983, shortly after 11 o'clock, from left to right, Dan Bradley, Brian Henderson, yours truly at the age of 29, who had just arrived 2 weeks earlier with a car full of physics books, but very little else to live on, and Dan O'Connell, a junior lecturer at that time, aged 38. This is, as far as I can see, the only photo I can find which shows both Brian and Dan together. It was taken at a very memorial time because it was 2 days after the board had actually accepted Brian's resignation, and exactly 1 week before this unfortunate, devastating stroke of Dan's there. The topic of the discussion, and that is really interesting, can be seen from what's on the board in the back. You probably can't see it, but if you look closer. It's called MQW, multi-quantum well semiconductors. How far-reaching this discussion was can be seen from the fact that quantum confinement of electrons in nanometer-thick semiconductor layers is still an interesting research topic in both nanoscience and quantum science 40 years later. And how far it was looking ahead, that the structures we discussed have since become essential building blocks of technology that we use in our daily lives today. You know that. An interesting side remark is that none of the 4 people depicted here come from a traditional, whatever that means, academic background. And you will see about this later on today. So let me just start where this all began. The word physics comes from the Greek, meaning nature. By 1724, the study of nature came to be called natural philosophy, as we can see from the title of the Erasmus Smith Professorship, the tricentenary of which we celebrate this year. As such, it is constantly developing as we as a human race keep on discovering new facts and understanding new processes. How wrong was Albert Abraham Michelson, the 1907 Physics Nobel laureate, when he said, and I quote, "The more important fundamental laws and facts of physical sciences have all been discovered. And these are so firmly established that the possibility of their ever being supplanted in consequence of new discoveries is exceedingly remote." The interferometer that carries his name, every undergraduate in physics around the world has to learn about the Michelson interferometer. Okay, that particular device was essential to confirm the quantum nature of light, postulated 2 years before Michelson said it in 1905 by Albert Einstein, and was only experimentally verified by Kimball and co-workers. And Jeff Kimball was one of the British Petroleum Venture Research Fellows at the same time I was that, so that comes later on. In 1977. And even more importantly, the device was and still is essential for the observation of gravitational waves. Proposed by Heaviside in 1893 and only verified by the LIGO consortium in 2015, and they got the Physics Nobel Prize in 2017. So this is more than 100 years later. So there is essentially a big change at the beginning of the 20th century. And as part of understanding the atomic structure of nature, the physics had developed into 2 directions at the time. One was basically the study of the nucleus, which was nuclear physics, which developed into particle physics, and the study of the electron shell, which developed into quantum mechanics, atomic and molecular physics, and ultimately on into more complex structures, namely solid-state physics. When E.T.S. Walton, still Ireland's only Physics Nobel laureate, was appointed as the 18th Erasmus Smith Professor in 1946, he came from a particle physics background from a highly respected and well-equipped Cambridge laboratory into a Trinity college and back into a home country that was struggling financially to survive the economic hardships that the emergency, as they call it, and previous internal struggles imposed. Despite excellent new appointments and immense efforts, it seemed practically impossible to establish a world-class research activity in particle physics at Trinity at the time. One should compare. It should be noted that the first 600 MeV, mega electron volt cyclotron at CERN cost 104 million Swiss francs annually in 1957. That translates to 500 million Swiss francs nowadays. At the same time, in 1957, Ernest T. Walton wrote a letter to the Taoiseach encouraging him to establish a research funding scheme which didn't exist in the country. And 10 years before, shortly after Walton arrived, the provost and himself went to Taoiseach de Valera and asked for funding, and de Valera granted a ad misericordiam sum of 35,000 pounds. That's not that little. It's 1.5 million in current funding to the entire college. So you see how difficult it was. However, 10 years after the 1957, in 1967, Trinity and under Walton demonstrated great foresight when they widened the research scope from nuclear and particle physics to the more modern and fundable area and appointed Winston McBriarty, a polymer physicist, in 1967. Coming from Belfast and Bristol, Winston went on to establish a world-class polymer physics laboratory and establish several highly productive research collaborations with local and international industries. That augurs well for this future. And in accordance with the normal practice at the time, E.T.S. Walton formally retired on the 30th September 1974, the last day of the academic year following his 70th birthday. I remember him well, still coming into the department regularly for many years afterwards and giving some most memorable demonstration lectures. An extended, almost 1 year-long period of search for his successor, the 19th Erasmus Smith Professor, followed. That was guided by the eminent Cavendish Professor of Physics at Cambridge University, Sir Brian Pippard, FRS. I cite the book of Eric Finch. One candidate from England did not hesitate on an initial visit to express considerable surprise at the condition of the department, with its relative lack of finance and quantities of old apparatus. He goes on saying, indeed, probably unknown to the candidate, it was around or at a little before that time that the idea was said to have been floated within college that the activities of the Department of Physics should be scaled down, or even that it should be closed altogether. This is not unusual, I should say. It has happened, unfortunately, several times in Britain, of course, that they did close. And it came up as a discussion shortly after I took up the job as head of department in the late 90s with the then physicist provost, Hegarty, who is here, that what the role of physics was it just a service department for engineers and biologists? You see, I fought this tooth and nail, and you see where we are now. Okay. Undeterred by the situation, this, and Eric calls him whirlwind from England, Brian Henderson accepted the offer from Trinity in 1974. Here he is. And moved over to Ireland with his family into a modern house on Savile Park Road in Dalkey, just around the corner from us. As he told the author, he felt greatly honored to be the successor of a Nobel laureate. Brian promptly used a large £30,000 grant from the college, plus two lectureships, by the way, which was remarkable and still is remarkable and for appointments, to supplement the research equipment that he had brought over from Keele University for his highly productive solid-state spectroscopic research. Games spectroscopists play with inside-out atoms, as he lightheartedly described his work to the students. Brian was born on the 26th of March 1936 into a coal mining family living near Doncaster. He was educated at Maltby Grammar School in South Yorkshire, and at the University of Birmingham he proved to be a bright, hard-working student, graduating with a BSc in physical metallurgy in 1958, and now, interesting, 2 years later, received a PhD. As a remark, I only had one out of my almost 80 students who achieved something similar, and he's professor in Munich. Okay, and his thesis was entitled The Lattice Spacings of Alloys with reference to electronic constitution, which is clearly a solid-state physics topic. Subsequently, the university elected him to a research fellowship. In 1962, which is actually 4 years later, Henderson joined the basic ceramics group at Harwell Atomic Energy Research Establishment as a senior scientific officer. He studied the structure of point defects produced by neutron radiation damage. One should say that was an issue and still is an issue in nuclear reactors and in nuclear weaponry, that you produce a lot of neutrons which cause a lot of damage to the environment around it. So this is an important subject which he studied even then. And one of his co-workers there, Tony Hughes, writes that it's a testament to Brian's achievements that just a few years later he wrote a definite review article on the defects in alkaline earth oxides with John Wirtz, a pioneer in the field from the University of Minnesota. So he got very rapidly involved in this. Taking the samples, large electromagnets and shelves of valve electronics with him, Henderson went on in 1968 to Keele University, first as a lecturer and became a reader 4 years later. He quickly established a strong research group with the help of a major research grant from the Science Research Council. One of his first research students there, Peter McGeehan, emphasizes that Brian was driven almost exclusively by his interests in the physics. He was a prodigious worker, expected the same of us, was fair-minded and wore his ambition lightly. He had a real nose for the cookery involved in crystal growth. And crystal growth is cookery, I can say, confirm. Another, Peter Waitman, describes how Henderson provided his PhD students with excellent research problems and the resources they needed to solve them, but allowed them the freedom to manage the research in their own way, intervening only when it was necessary. A couple of years later, in 1974, as I explained earlier on, Henderson moved to Dublin and started immediately to dispose of significant amounts of older equipment. In due course, a nitrogen liquefier was purchased, which was still operational when I came here. To get down to the very low temperatures, 4.2 Kelvin, minus 269 centigrade, 4 degrees above absolute zero, that were needed for much of the spectroscopic work. A helium liquefier was also acquired. It proved very difficult to maintain this complex machine and liquefy significant and useful amounts. I still remember various unsuccessful attempts to revive this machine located in the ground floor of the Fitzgerald building during the 1980s and 90s. While liquid helium is nowadays commonly used and widely available for medical MRI machines, for the magnets to cool, it had to be purchased and imported from British Oxygen by ship at great expense. And I had on one occasion, that an empty 500-litre container was delivered to us, together with a bill for £2,500. And what had happened is it was filled in Britain, but it got stuck in Liverpool because of a docker strike. And all the lovely liquid disappeared into thin air. But since it was filled, of course, British Oxygen wanted to have their bill paid, which was a big fight on our hand. The department that Brian envisaged was a modern solid-state physics institute. He strengthened interdisciplinary collaboration by taking an active role in the appointment to chairs in chemistry of Sean Corish and Bob Lloyd, both of whom had a strong interest in materials science. As such, he created the precursor to the joint advanced materials degree, which is still going strong, and to the advanced materials and nanotechnology institutes of later years. Henderson also emphasized that physics not only included experimental work, but also theoretical and applied research, and therefore changed the name to Department of Pure and Applied Physics in 1976. In that way, he also established physics an integral part of the technological development in Ireland and ensured that Trinity became one of the major players in the subsequent industrial and economic well-being of the country. That's very important. I should maybe point here, there's some of Brian's books, and you see I believe this is the class of 1976, with several people, all male students at the back, and several people here at the right, Eric Finch, the ones who are here, and then I can't see it totally. There is E.T.S. Walton and a very proud Brian Henderson, and then Vincent McBriarty and Robert Barclay on that here, and several other people who are no longer with us. During his tenure at Trinity, Henderson made very highly successful appointments. The first one was a Trinity graduate with a PhD from Cambridge, Robert Barclay, who is here, who returned to college from Cambridge in 1974 to help Henderson establish his spectroscopy group. In 1975, Dan O'Connor, another spectroscopist from Stirling, joined. He died suddenly in 1990, aged only 45. In 1977, a surface chemist, John McGill, was appointed. In 1978, Mike Coey, who is here, was appointed, and he went on to become a world-leading expert in magnetism and an FRS. In 1979, Iggy McGovern, who is here, another surface physicist, joined from Pennsylvania and Wisconsin, and in 1980, James Loney, who is also here, a plasma spectroscopist from Belfast, joined. And in that very same year, 1980, a world-famous laser physicist was offered a personal chair in optical electronics coming from Imperial College, Dan Bradley, FRS. With such excellent dynamic staff and quite a few short-term lecture appointments along the way, Brian created a flourishing modern physics department and a lasting collegiality and esprit de corps amongst its whole staff that can still be felt today. For instance, he created the departmental coffee at the time at 11 o'clock, which is still going on. Remarkably, within a decade, Henderson had increased the academic staff to 12, which means doubled the staff from 6 in 1969. In that way, Trinity Physics reached a critical mass with which it could compete internationally in solid-state physics research and establish an international reputation that it still enjoys today. Brian extended the space for physics into what became the adjoining Dixon Laboratory, formerly the Dixon Hall, which, as I said, has taken place, given way to the SNIAM building now. The physics syllabus was greatly updated from something which was very close to turn of the century at the time, I believe. Many more tutorials were introduced. Tutorials was new. And the final year research project, a concept that still exists and is very popular with both staff and students, was introduced. He also strongly supported the founding of Dublin University Physical Society. And what happened now? Here? And here, Eric provided me with the first record of the meeting, dated February 1977. And in addition to Brian's signature as a member, there's Eric's signature and several other signatures, which became, several of the signatories, I should say, which became professors and senior lecturers in DCU, in in Cork, in UCC, and in Trinity, of course. And should I say, there is also on the other side the name of a visitor called Mary Kelly here, which in discussion with John, we assume could it be the current treasurer of the Royal Irish Academy and our deputy chairperson of the board? The time would be right. Okay, in '76, Henderson became a fellow, and 3 years later he earned an SCD from Trinity, and he was elected to the Royal Irish Academy in 1981. In his very direct, no-nonsense way, he told me shortly after my arrival in autumn '83 that he really loved Bavarian food. And would it be not nice to call out to our house for a dinner of Wiener Schnitzel? We duly obliged and decided to have Leberknödelsuppe, liver dumpling soup, as a traditional starter. And we still remember the face of the butcher in Bray when he saw the minced beef liver come out of the machine. For us, coming straight out of the student life, giving a dinner party was a new experience. The evening with Sheila and Brian Henderson, Mary and Cyril Delaney, and Lisette and Robert Barclay turned out to be a great occasion with the discussions concerning everything, covering everything from Trinity affairs to music. Both Brian and I played piano, to international soccer. Brian resigned in 1984 to take up a professorship in Strathclyde University in Glasgow, but he retained a lifelong affection to Trinity. He was eventually elected to honorary fellowship. Following his funeral in Yorkshire in 2017, Brian was buried not in a churchyard or cemetery, but most unusually in a specially authorized grave shared with his late wife, Sheila, on their family farm. Moving on to Professor Bradley. When asked why I ended up in Trinity College, I usually point to a little brown booklet. That is my Dr. Reanat thesis from 1983, full of equations and simulations. Reference 2 is D.J. Bradley, High Power Pulse Laser Science Progress 1969, followed by numerous other references with the same co-author. Thus, when I saw an advertisement for a British Petroleum Venture Research Fellowship with him in Laser Focus World, I immediately applied. And to my great surprise, a few weeks later, our bright orange phone rang, and a voice with what I now recognize was a strong Northern Irish accent said, "Why don't you come over for an interview?" So we put our 3.5-year-old son into the car and drove the 2,000 kilometers from Regensburg to Dublin, and the rest is history. Daniel Joseph Bradley, Dan, was born in Derry City on the 18th of January 1928. I should switch over so you know whom we're talking about. The son of John Columba Bradley, a post office worker, and his wife Margaret née Keating, one of 10 daughters from a farm near Cashel, County Tipperary. He was the second born of 4 surviving children, with an elder sister and 2 younger brothers. Notably, Dan's paternal grandfather, William John Bradley, was head postman for the Derry postal area and also an alderman between 1920 and 23 in Derry Corporation, at the time when the city had its first Catholic majority council and mayor. After completing the first and second parts of the technical school examinations in electrical engineering, Dan worked for 3 months as a telegraph boy. He subsequently enrolled at Lumen Christi College, a high school in Derry, where he obtained his secondary school senior certificate in 1945, surprisingly not taking physics, with a satisfactory high standard to warrant the university scholarship. As a maths scholarship in Queen's University Belfast was only a half scholarship and therefore insufficient to cover all costs, he did not take up a place in Queen's, but instead enrolled with a full King's Scholarship and St Mary's Teacher Training College in Belfast. After completing the degree, he started working as a primary school teacher at various schools in Derry between 1947 and 53, while he at the same time studied a part-time special BSc degree in mathematics at the University of London. As this degree allowed him also to go to London to teach in secondary schools, he moved there in 1953. And in October of that year, he enrolled at Birkbeck College to study part-time for a BSc Special Physics degree, becoming a Ravenscroft exhibitioner and a college exhibitioner. He originally wanted to do another maths degree, but because he already had a maths degree from the University of London, he wasn't able to sign up for that. They suggested that he should do physics instead. And then the question of not having studied physics at leaving certificate arose. It appears, Donald tells me, his son Donald, that he simply ignored the written requests from the registrar to confirm that he had studied physics. And as Donald said, he did well enough when he got there that it didn't matter in the end. One other thing was that he caught TB, and he had to spend time in a sanatorium on what was called the scholars' ward whilst he recovered, and he studied at the same time, so hard life. Only the final honors year was spent as a full-time study in Birkbeck, and he graduated in 1957 as top of the year for the whole of the London University. An assistant lectureship at Royal Holloway College enabled him to undertake a PhD research program under the supervision of Professor Sam Tolansky immediately afterwards. The topic of his chosen research was the scanning Fabry-Perot interferometer. In the late 1950s, there was considerable interest in developing such scanning techniques to enable the recording of emission spectra. At Royal Holloway, Dan also met Winifred O'Connor, a 1951 botany graduate from the University of Liverpool, who was also an assistant lecturer. They married in 1958 and they have 5 children, Sean, Mairead, Donal, who became a distinguished physicist and was elected FRS in 2004 and appointed CBE in 2010, Ronan and Martin, who is here. With an increasing international reputation, Bradley was promoted to a readership in Royal Holloway in 1964. He continued research and development on Fabry-Pérot devices and their applications, and introduced a particularly novel device which was later used to tune short pulse lasers and was successfully commercialized. During that period, his interests moved increasingly towards ultrafast electron optics, laser development, diagnostics, and applications. And it should be pointed out this was only 4 years after the first demonstration of a ruby laser by Maymont in Hughes Research Labs in the US. So this was very rapid development. His appointment and headship in physics at Queen's in 1966 allowed him to, only 4 years after the PhD as a professor and head, allowed him to establish one of the most productive and influential laser physics groups in the whole of the world. And you see here Dan in 1969 in the middle of his 80 research group members, together with a flash lamp dye laser in the front, which they wheeled out of the lab into the teaching lab for the photo purposes. The Bradley Group made many records, and that's what sort of got him cited in my thesis, and was particularly noted for the development of dye lasers, which allowed the generation of wavelength tunable pulses of picosecond duration that became very important in medical applications only a few years later. Pulses of a few picoseconds, that's 10 to the minus 12 seconds, so 1 with 12 zeros at the back, were routinely achieved, and Bradley was also instrumental in the formation of one of the first laser spin-out companies helping establish Electrophotonics Limited in Belfast, who rapidly commercialized the outputs from the research group. And I, from my own PhD, still remember having quite a few devices in our lab in Regensburg, which were from Belfast. And some of the designs we copied, if I may say. He also developed at the time something which is slightly like an inverse television camera, to a so-called street camera, to record and measure these fast pulses and fast events, which are extremely important in the biological area there, and also in the molecular physics area and in semiconductor physics as well, called the street camera, which then also was commercialized fairly rapidly by Headlamp Photonics in the UK and Hamamatsu Photonics in Japan. That's what caught my own graduate student attention as well, because we would have loved to get one, but we didn't get the funding from the German Research DFG Council, because one of them cost 500,000 Deutschmarks and we didn't get the money. Unfortunately, the increasing stability and political violence in the early 1970s effectively obstructed Dan's plan to build a government-funded national laser facility in Northern Ireland, and it ultimately went to Rutherford Lab in Oxfordshire. During 1972, more than 500 people lost their lives, over half of them were civilians. So that was a hard time. With neighbors affected by the violence, by 1973, Winifred, who told me during a dinner in the provost's house with John Hegarty's provostship, on the John Hegarty's provostship, they became increasingly concerned for the safety and well-being of their young family. On the funny side, however, they decided, given that Dan was traveling extensively to international conferences throughout the period, that a good watchdog would be a sound investment with respect to their family safety. Much against the advice of several colleagues in the physics department at Queen's, Dan decided to get a Kerry Blue Terrier, a breed generally known for their dynamic temperament, exuberance and aggression. Yet, when Dan made up his mind, no amount of dissuasion could change it. The dog, called Bluebeard, appropriately named, however, did not last long. After it had seriously bitten both neighbors and family members, it had to go. And Donald tells me that he still bears evidence to this on his forearm. Or maybe you do as well. Okay. Eventually, the Bradleys decided to move away, and Dan accepted a chair of optics at Imperial College in that October. Quite a lot of people moved with Dan to Imperial and became leaders in the UK and international laser community, including Henry Hutchinson, Jeff New, Wilson Sibbitt, and Roy Taylor. And many of them are FIS, and I should say the color picture at the bottom is at a conference in Killarney in honor of Dan, and on the left-hand side, on the very left, it's Wilson Sibbitt, who is an honorary graduate of this university as well. And on the right side, it's Jeff New from Imperial. There's also the invited speaker, Shalai from Purdue. And you can see Dan and Winifred in that here. By 1979, Dan, by then head of department, had become increasingly frustrated by administrative problems, especially those relating to the processes and limits of promotion and appointments of young staff. We know this. He felt that the college was not fairly distributing the limited positions that were available for promotions, naturally believing that physics had better cases than some other departments. Hence, when he was approached by Brian Henderson regarding a new personal chair at TCT, he accepted. By doing so, he would free a post for someone else to become a professor. As Dan mentioned in Personal Conservation, his decision was made much easier by Margaret Thatcher's policies, namely to offer extra incentives to senior academics to leave academia. He had, of course, maintained a close connection with Ireland, both professionally and personally. For some time, he had been assisting the National Board of Science and Technology as an assessor of grant applications, and they had approached him to become more actively and directly involved in their activities, with particular emphasis on developing links with European and UK science programs. He also, for many years, had a family home near Ardmore Pier in Kilkere on the Galway Gaeltacht, and in 1980, therefore, he took up the newly established chair in Trinity in optical electronics. Dan's plan in establishing a major research group in Trinity was to address two principal themes: the application of semiconductor laser devices, primarily directed towards optical communication and optical logic, and the application of ultrafast lasers to investigate the dynamics of molecular, polymeric, and biological species, in which field he proposed the application of the street camera as, in fact, the only real-time diagnostic with ultrafast resolution. It's worth pointing out that nearly 20 years later, Science Foundation Ireland selected optical communication and the biosciences as the country's two major development themes and funding avenues. And it's also maybe worthwhile pointing out that the semiconductor laser area developed very, very successfully with Optronics Ireland under John Hegarty at the time. Then, in 1981, Professor Bill Watts, who had become the provost at Trinity that year, asked the board of the college to agree to his nomination of Dan as bursar. A requirement for the appointment, however, was that the nominee was a fellow of the college. Consequently, to meet Watts' requests, the immediate assent of the fellows, not on Trinity Monday, by the way, was required by the board to elect Dan to a fellowship. It had been pointed out by Eric, for instance, that it is extremely unusual for such an election not to occur on Trinity Monday. Yet, following the expedited election to fellowship, Dan was appointed bursar. Some fellows did voice concerns that there might be undue diversion of Dan's time from his research activities, and he only occupied the post for 18 months. As he pursued a punishing schedule to build up his laboratories and to re-establish an international competitive research reputation in what was now a new research area of his. The establishment of a research group in Trinity was difficult. Internally, the funds were simply not there to build up an expensive lab that Dan intended. To recruit students, he insisted on teaching in the undergraduate laboratories, where he knew he would meet the complete student population and where his personality, flair, and teaching skills would, as it had done in the past, attract potential recruits to his research group. I should say that, in fact, he had about 60 postgraduate students, and one unanimous opinion of all the students that I've heard of was that he was incredibly inspiring. He also procured funds to convert two Dublin Georgian houses on 23 and 24 Western Row on the periphery of the Trinity College into a suite of laboratories. A major achievement was the award of a very substantial British Petroleum Venture Research grant. And here is the press, both Irish Times and Irish Independent here, remarks there. British Petroleum, the Venture Research Unit, established and managed by Don Braben, was an initiative of BP from 1980 to 1990 that provided £20 million funding in research to about 30 researchers and small teams from Europe and North America. It aimed to fund determined researchers who had identified significant gaps in existing knowledge or questioned current scientific thinking. Trust and freedom were considered essential aspects of the VRU approach. Dan's proposal to utilize ultrafast laser technology to investigate reaction pathways and to probe the structure of biomolecules perfectly met with such an objective, and the proposal fundamental optoelectronic studies of semiconductors and DNA with ultrashort laser pulses was funded at a level of 150,000 Irish pounds at the time, and then 50,000 extra, so 200,000 pounds, as it said in the press there. Together with Professor John Kelly, chemistry, and Professor David McConnell, genetics, he began establishing a team to carry out his program. A particular futuristic plan included the two photon excitation techniques to analyze base sequences in DNA as a novel way for rapid sequencing. This work later led to a very successful broad series of experiments undertaken over many years that were carried out by John Kelly and his collaborators. By the end of 1983, Dan had sourced funding to appoint several postdoctoral research fellows to accelerate the research developments. However, on Friday, the 21st of October 1983, he suffered a severe debilitating stroke. One of the recent appointed postdoctoral researchers, Christina Johnson, arrived only days after this tragic event, while another, Lawrence Rickey, was still negotiating his contract. Coincidentally, Chris was appointed as the US Undersecretary for Energy and Environment by Professor Obama in 2009 and awarded an honorary degree in Trinity in 2010. A third, today's speaker, had arrived just before and was left with the others to work tirelessly in the lab to keep an extremely complex, and it still would be difficult nowadays to keep that laser going, and futuristic laser system operational, and to initiate a funded research program. It came as an immense shock when Brian Henderson called us into his office on that Friday afternoon to tell us about Dan's illness, and the real severity only sank in when we visited him in hospital during the following week. Out of the blue, actually, Brian appeared at our house door on Sunday afternoon. I should say it took over a year to get a telephone at the time. So personal visits were the only mode of rapid contact. With a bunch of overhead transparencies, you remember these things which were used before the PowerPoint existed, and telling me that he needed me to take Dan's first year lecture on Monday morning at 10 o'clock in the physics lecture theatre. Without much experience in teaching huge classes, about 120, and English per se, I must have completely stunned the class with trying to explain the Einstein model, first-year engineers, by the way, of specific heat to them at a level that was probably 10 to 100 times higher than they were used to. Coincidentally, I should say, one of the students in the class, it turned out from conversation, was a certain Patrick J. Prendergast, the future 14th provost of Trinity. As a result of the stroke, Dan's mobility was restricted and his speech severely impaired, and he retired in 1984. He continued to travel extensively and participate in numerous national and international conferences. In time, illness restricted his travel, and the latter years he was cared for in Bloomfield Care Home in Rathanum and died in Tala Hospital on the 7th of February 2010. And a bench is placed in his memory outside the Fitzgerald building. I hope that you agree with me, building on 3 centuries of natural philosophy, research and teaching in Trinity, both Brian and Dan were instrumental to the current day research reputation and successes of the School of Physics. They built the modern physics in Trinity and established physics as an important national subject for a technological Ireland. Its high quality, up-to-date teaching program and its outstanding esprit de corps, which I should say was one of the real reasons which kept me here, are remarkable. Their legacies still endure in the college's strength in optoelectronics, nanotechnology, and advanced materials, where colleges, by the way, ranked internationally in the top 100. Hence, it was not surprising that at one time around the millennium, the school had no less than 4 fellows of the Royal Society. And here they are: Dan Bradley, Dennis Weir, Mike Coe, and Sir John Pettica. And with that, I hopefully showed you how, from very difficult beginnings, the 2 people brought Trinity and Irish physics into the modern age, and what their lasting legacy, which is the success of physics today. Thank you very much.
it's just my job to bring the session to an end. I just want to thank Werner, that was amazing. I think there's something really fantastic to hear about the technological and scientific advancements along with those personal stories, down to your orange phone. I can imagine it. It's really, really brilliant. And especially, as I said, as we celebrate Physics 300, it's really special to have this lecture today. I'd also want to thank all of you for turning up. John Hagerty, it's brilliant to have you here as well amongst everyone. And I noticed as I was sitting there as well, I could hear people mumbling and nodding and relating to some of the photographs and really kind of, I suppose, going back to those days when they knew those people who were here. So it was really lovely to hear that. I want to say special thanks to Susan Cave. Normally when we have somebody doing sign language, we have to change in and out about every 15 or 20 minutes. And it's very arduous actually to do a whole long lecture. And I know she's translating this. And I'm sure she knows way more about physics now at the end of it. I noticed actually on your slide, Sean Prunty used to teach me in UCC when I did a Lec Eng there. So it's amazing how you begin to see all of these connections and how everything had such an influence everywhere. So the final people I would just like to thank, I'd like to thank Claire Tracy in my own office. So Claire manages this every year, and I have to say she takes special pride in these lectures and really, really thinks about them and plans them. And she's a very unassuming person. I don't think she's even in the room at the moment, but I just wanted to say thank you very much to her, and thank you to the others in my office who've been helping with this as well today. But most of all, thank you all for attending on such a wonderful day, and thanks again to Werner for an amazing lecture.